So let's look at solving this exponential equation. It's the kind that we've taken a look at before, because if you notice on the right-hand side, the 81 can be written as 3 to the 4th power. So let's write our next statement, which is 3 to the x plus 5 equals 3 to the 4th power. And if you'll recall, we had looked at a property earlier that if the bases match, can match the exponents. So then we can, as our next statement, say that x plus 5 equals 4, and so x is equal to -1. And that's a perfectly fine answer, though you'll notice that I usually write it in the form of a solution set, so -1, like so. Now I'm going to scroll down a bit and take a look at our next example. The instruction for this is going to be a little bit more detailed, which is solve, giving both an exact answer and a decimal approximation to 3 places. Now I'm going to scroll down a bit, and the one that we're going to solve is 3 raised to the power of x plus 5 equal to 79. And you can see that the solution will be very similar in value to the previous example that we just did, because 79 is not much different from 81, but unlike our previous example, we are unable here to match the bases because you cannot write 79 as 3 to some integer power. So now would be a dandy time to stop and see if you can use your rules of properties of logarithms to see if you can rewrite this a little bit. Otherwise, we're just going to go on, scrolling down a little bit further. I'm actually going to use 2 different methods to solve this, and it really doesn't matter which one you use. So I'm going to do the method 1 over here on the left. And what you can do is you can just rewriting this as 3 to the x plus 5 is equal to 79. We can use that little skill that we learned about how to transform an equation in exponential form into one in logarithmic form, which is the 3 goes to the other side and becomes the base of the logarithm. And then we write that x is equal to log base 3 of 79 minus 5. And this guy here is our exact answer. Scrolling down just a little bit. In order to be able to type this into your calculator, you would then need to use the base change formula and write it as either log or ln. So I'm going to just choose log for no particular reason, over log of 3 minus 5, which, by the way, is also an exact answer. And then moving down just a little bit more, if you type this into your calculator, using my usual practice of writing down a couple of extra decimal places before my final answer. And I believe we asked for 3 places, so minus 1.023, which is not that much different than a minus 1 that we had in our previous example when we were looking at 3 to the x plus 5 is equal to 81. So that's method number 1. I'm just going to scroll up a little tiny bit and show you method number 2, which is equivalent. Some students just find the thinking about it a little bit easier. So let's take a look at method number 2. And method number 2 takes the original equation, which is 3 to the x plus 5 equals 79. I'm just going to move the 79 over a little bit for a reason that you'll see in a second. And then actually takes the log or the ln, doesn't matter, I'll take the ln here, of both sides. And provided that we have nice positive numbers, then this is absolutely a legitimate thing to do. And then notice how we can now use our properties of logarithms to bring the exponent down using the power rule. So then x plus 5 is equal to ln of 79 over ln of 3. Notice how we could have used logarithms here instead. And then we get that x plus x equals, solving for x, is equal to ln of 79 over ln 3, which is minus 5, which again is an exact answer. And then, as usual, you could plug this into your calculator and get the same answer as before. So two different methods. One is to use the conversion of an exponential equation into a logarithmic equation, and the other is to just log or ln both sides. Always okay, provided you've got nice positive quantities and you're using the same base in the logarithm on both sides. And I'd like to give you one further caution, just going to scroll down a little tiny bit, which is looking at this expression right here. One helpful tip to note: you must not be seduced by the dark side of the force here. Log base 3 of 79 minus 5 is not equal to log base 3 of 74. And the reason for that is I'd like you to think about this in nice big brackets. It's the same thing as having something like the square root of 79, where the negative 5 is not allowed to creep underneath the square root sign. So make sure that you don't do any bad math here and combine stuff within the logarithm and stuff outside the logarithm together by accident.